Hi everyone. In this lecture, I will start designing the first microservice that I will implement, which is order service. I will use hexagonal architecture and clean architecture concepts before implementing the service. To show you the components clearly, I will use Excalibur website and create the design diagram. So let's start with a traditional three-layer approach. I will first put the API layer. In this layer, we will have the REST controllers that will serve to an user interface. So here, there will be some kind of a REST client or user interface. Then I will have the domain layer. In this layer, there will be the business logic of the application. In the layered approach, each layer will depend on the next layer. So I will put a depends arrow from API layer to domain layer. Then I will put the data layer, which has the implementation of data source operations. So it will communicate with a data source, let's say with a relational database. Following layered approach, business layer will depend on this data layer. As you can see in this picture, if I want to change the data layer to use another data source, it will directly impact the business layer, because business layer depends on the data layer. So any change on the data layer will require to recompile or redeploy the business layer because of the direct source code dependency. Now I will start applying clean architecture principles. The first thing I need to do is to make the business layer independent and stable. For that, I need to remove the dependency from business layer to data layer. To do that, I will put a data layer interface in the domain layer. And remove the dependency arrow. Data layer interface is the output port definition that needs to be implemented with an adapter. This interface will include all data source related methods that domain layer requires to complete the business logic. So whenever a data layer operation is required in domain layer, I will use this data layer interface in the source code. So I don't need to have a dependency to the data layer from business layer. Since this is an interface, it will require an implementation class, which is called secondary adapter in the hexagonal architecture. As mentioned, the implementation of this adapter will be in the data layer. Data layer needs to depend on the business layer to implement this interface. I will show this with a depends arrow here. As you see, we have reverted the relation. Now, data layer depends on the business layer. As I mentioned, this is called dependency inversion principle. With this change, we immediately got two advantages. First, business layer can be developed and tested without requiring a real data layer implementation. Second, when we implement data layer, we can change this implementation without affecting the business layer. as long as we obey the contracts on the data layer interface, which is in business layer. Great. The next thing we need to think about is how to use this interface while coding in the domain layer. At this point, we will need to use dependency injection, which will complete the dependency inversion principle and allow us to use an interface without requiring the implementation at compile time. At runtime, I will run both business layer and data layer together, and the data layer adapter will be used as the implementation of the interface that is used in business layer. How can I run both business layer and data layer together? For this, I will use another component. I will call it as container. To make this concrete, if you think it as a Spring Boot application, this will be the component that has the Spring Boot main class. In this component, I will have a dependency to business, data layer, and also to API. So when I run this Spring Boot application, it will have all components as jar files, so that the data layer interface will find its implementer in the data layer at runtime. This is the main principle on a clean architecture. We use dependency inversion and polymorphism, and then apply dependency injection to use an interface at compile time, which will have the implementation class at runtime. While writing the order service, you will see that even though I use dependency injection, I will not add Spring Framework dependency and annotations into the business layer classes. So the core logic will also be independent of any framework. I will accomplish this using a bean registration class in the container module. Here we have defined the output ports and the implementer of that ports as secondary adapters. In a clean architecture, we should also define the input ports in the domain layer. I will name this input port as domain layer port here. This port is also an interface when we think it in Java, and it will require an implementer, and it will be implemented in the domain layer itself. So I will add a domain layer implementer in the domain layer. So who will use this input port? As it is obvious, the API layer will inject and use the input port using dependency injection. And at runtime, the method calls will be delegated to the implementation, which is in the domain layer. In hexagonal architecture terms, the API layer that uses the input port is a primary adapter. It is an adapter because it can be easily changed without touching to the domain layer, thanks to the usage of the input port. Remember that the data layer adapter in the data layer was a secondary adapter in clean architecture terms. Let's extend this picture with some other possible components. Let's say you need to have an external service call in business layer. So I have an external service here. According to clean architecture principle that I just applied, how can we integrate this external service into the application? Again, I will add a port into business layer. This time I will call it as external service port. And then implement it in the external service with an adapter, which is a secondary adapter in hexagonal architecture terms. I will also add the implements arrow from the data layer adapter to the data layer interface to make it clear. Then I will add a messaging component. Again, applying dependency inversion principle, I will add a messaging port interface in the business layer and implement it with a messaging adapter in the messaging component. Let's say this adapter will use Kafka. However, as mentioned, when you want to change the adapter with any other messaging technology, it will be a painless operation, thanks to the clean architecture that you use. So in future, you can easily change the message bus from Kafka to any other solution. In the end, the core logic will be the most independent and stable components in this application, and it will allow to develop and test the business logic independently. So here you see the order service components designed using clean architecture. Alright, in the next lecture I will start implementation and create the modules of order service using clean architecture in IntelliJ. So I will see you in the next lecture.